morning. Section 7.6. We are continuing rational expressions. However, today we are going to set them equal to some other rational expressions, and we are going to create equations today involving rational expressions. Okay, so let's quickly review what we did yesterday. We further computed rational fractions, things with rational fractions, and basically this is called a division of rational fractions. You see some fractions on the top and on the bottom, but they weren't usually single fraction on the top or bottom. There were more than one items, so all you need to do is you need to combine them into one. It is combined into one. And then you flip the bottom and multiply. That's what we did. And those stages were explained in this part. We pretty much follow three-step method in every question yesterday. Okay? So again, these were not equations. You may say, oh, there is an equal sign here. No, this equal sign was put here so that you can just reduce this into something and they are still equal. But what we do today is there is an equal sign or again, but on the other side of the equal sign you also have either fractions, numbers, or something else. So these are the real equations. We are going to solve equations like this. Again, solving means isolate. We'll get the variable alone on one side, and on the other side you will have only pure numbers. That's the idea today. But why don't we first make the final definition of rational equations. Rational equations are equations, equal sign symbols will show up somewhere, involve fractions, ratios. So any equation involving a fraction, such as you have this, and we call it a rational equation. You may have more than one. This one has 3. This one has 3 as well, with a lot more complicated denominators though. These are all called rational equations. So whenever you see any kind of equation similar to one of these, here's what you need to do. You're gonna follow 5 steps. Let me first read through quickly the steps, and we will apply that into first question. First, we factor the denominators of all rational expressions. So you check out what you have in the denominator and break them. Such as, can you break this denominator? No. Can you break this one? No, it's already 3 simple. However, can you break 6? Can you break 6? Yes, you can. You need to break 6 into 2 and 3 and proceed to the next step. So some questions require only very simple factoring. Some other questions, take a look at this. Can you break this? Yes, you may need to factor by using the skills you already obtained from chapter 6. So you need to factor this into x minus 6, x minus 1. How did I do this? By trial and error game, we know already. 2 numbers multiplying to 12. No, this is incorrect, sorry. 2 numbers multiplying into 12 and adding into minus 7 is minus 3 and minus 4. It's not 6 and 2, it's 3 and 4. Negative 3 and negative 4. And can you break this one? No. No. So some questions may involve polynomial factoring, or quadratic factoring is much proper name for it. And what is the second part? It says identify the restricted values. You don't have to worry about this. We will worry about this once we get the solution. We will worry about this later. I will explain how this makes a difference, but you don't have to do it in step 1. So I'm going to take this part off. We'll never do it actually. Only factor in step 1. That's it. Second step is we are going to identify least common denominator of all denominators. You're gonna find out all denominators, but you're gonna find out LCD of them. and you will multiply that LCD from both sides. Left side and right side must be multiplied by that LCD you determine. Step 2 is most important part, because if you identify the LCD wrong or incomplete, not sufficient LCD, the whole other steps is gonna mess up. You will never get the right answer. Step 3 will fail, 4 fail, 5 fail, okay? So take your time in step 2 to choose the right LCD. There is only one LCD you must come up with, and that's the most efficient one. Okay, I will tell you how. We've been already doing that actually. We'll just repeat that same process over and over. Again, once you determine this LCD, we multiply, and the rest is isolating steps. You need to isolate the variable from the equation. And step 5 is kind of optional. If you have time, you do it. But I strongly recommend paper testers. You need to do step 5 to get full credit, because you need to make sure your solution is right. Otherwise, you lose credit if your solution is. But computer testers, yeah, you punch in the numbers, it will tell you right or wrong. But step 5 is necessary for paper tests. Okay, so we're ready to apply these steps in question number 1 in our first homework. Good. Any questions? Alright, first, can you guys factor these denominators? Let's identify them. I have 7. Can you factor it? No way. 3, can you factor that? No way. Why? No. So this is an easy one. Step 1, no step 1 required. Okay? So we start easy, no step 1 required. Step 2, identify the right LCD between these 3 denominators. There are 3 denominators here, 7, 3, and y. I call this LCD the bullet. The bullet. Why? What do you do with bullets? Alright. I don't know. I'm trying to put this in a nice way, but what do you do with bullets? You don't play with them, of course. You shoot people, not people. You shoot things, alright? You hunt. Okay. Yeah, I'm coming from a part of the earth. We shoot people with that, but but you here just shoot targets in safe places. Okay. Yes. Why do we need to pick a bullet and shoot things? Because there are bad guys here. These are bad. We hate denominators. Denominators, bad. We need to kill them. Really. I need to wipe off all these 3 so I can have nice things on the numerator that I can isolate. Okay? So, but there are 3 monsters here, 7, 3, y. You need to choose a bullet strong enough to kill all 3. So what is that? You create your bullet, or we call it LCD. It's gonna be combination of all these 3 monsters to wipe off all 3. But you need to be most economical. You don't pick a bullet in the size of a missile, not too big. It's just the right small size to clear all 3. Okay? So what you do is you pick how many different factors you have. If there are already ones matching, you don't double count them. Only choose the distinct factors. What is distinct? Everything is distinct here. There is no overlapping, right? 7, 3, y. So your LCD, your bullet is all 3. Okay? But what if there was maybe 7 was 21? What if this first one was 7 and 3? Are you gonna take another extra 3 here because 7, 3, 3, y, 7, 3, 3, y? Now if this was 21, Since these three are already matching, I wouldn't double count it. Always take one from each distinct factor. 7, 3, 3. These three already counted in 21. You don't have to double count. Okay? So always one type at a time. 733 is your LCD. You take that LCD, this is your bullet now, and multiply both sides with that. So put 5/7 in parentheses. So this is set up. First, don't rush into anything. First, set your equations ready for multiplication, for massacre. Okay? Now, put your bullet to both sides. This is your bullet. Now shoot. I shoot this bullet to first guy. I shoot this bullet to this entire crowd. It's a crowd here. It's not just single. So remember, each of my word is actually has a meaning. This is single. This is crowd means I will distribute. This is single guy, one guy only, 5/7. So I will just put 7, 3y next to that guy. That's how you should put the bullet to that target, 5/7. But this one is not going to go into the first target only. There are two targets here. You need to distribute this bullet to both. Have you noticed that I did not multiply 7, 3 and y together? I didn't say 21 here. I kept them separate. You do the same. Keep them separated. Don't multiply 7 and 3 yet. Alright, can you see what's happening here? I had 5/7. Now I have my bullet next to it. I had 4/3. I have my bullets next to it. And I had 3 y's, a bullet everywhere. So later stages in question 2 and forward, you can actually skip this step. Put the bullet you picked next to each guy automatically. First, second, and third. 1, 2, 3. That's it. You can skip this step. You don't have to show that anymore. I just showed it for the first time. Not necessary anymore. But this is what's going on. You are multiplying both sides. I'm step 3. I'm multiplying both sides with the LCD bullet I picked. This one is single, only showed up once. This is double, showed up in 2 places. So kinda the bullet is going 3 separate locations. Clear? Now let's do what bullets does. They kill things. Look, but this bullet is only gonna kill. There is only one little monster. So the other piece, 2 other pieces of the bullet is wasted. 3 and y stays. Alright, how about this one? Which one does this bullet kill? Only 3. 7 and y are left out. There are still 2 pieces left. And which one does this one kill? Y. What do I do with the left out pieces of the bullet? Yes, you multiply out them. Everything now multiplies out. So 3y and 5. 3y and 5 should multiply. What is the result? 3y and 5 multiplies. If you actually multiply these two and put y next to it, it is 15y. Put equal sign. 7y4 multiplies into 28y. 733 multiplies into, yes, 3 times 3 is 9, 9 times 7 is 63. Oh my god, look at this. Your monster. Why was it monster? Why was it ugly? Because we hate denominators. Denominators are gone and this is beautiful. Beauty, right? Why is it beautiful? No denominators. Yeah, it's beautiful, but it's a little bit fat. Why do I call it fat? Because 15, 28, 23, they used to be skinny, small things. 5, 4, 3. It's a lot fatter now. 15, 28, 63. but it's still beautiful. I mean, I like 15, 28, 63, right? Big numbers, but still, as long as I don't have denominator, I'm okay with that. Okay? So step 3 is over. We multiplied both sides with the bullet. And monster's dead. At this stage, you should not have any denominators. If you have a denominator like this, that means you did something wrong. Go back to step 2 and 3, do it again. You did something wrong. All denominators must be wiped off. Alright, what is next after this? Step 4 says solve. Solve means isolate the variable. Y should be collected together and left single. So I have two spots with y's, so they need to come to same side. So we need to take one of them and remove it. Which one? 28. You can get rid of 15 if you want and bring to the right, but if you like y's on the left, why not? 28 minus 28 both sides, so 28y disappears from this side. You are bringing it to the left. Looks, it's on the left side now. And 15 take away 28 is negative 13. And I divide both sides by negative 13 now. I don't like the numbers though, but what can we do? Y is negative 63 over 13. That's it. They don't cancel. Do they cancel? 63 is 6 and 9. No, it's not. 7 and 9, right? Unfortunately, 13 does not factor. Does it factor? So you can cancel these? No. So you don't have to break them. This is it. 13 is prime. It won't cancel. Thus 13 goes into 63 whole. As a whole number. 4, 5, no. 6, no. So this is it. This is the answer we need to test. Alright, now, warning. Sometimes the answer you obtained may be fake answer. What do I mean by fake? What's that?
You got the least common denominator, right? Wrong?
No, not because of that. Maybe you did everything right, everything correct. There is a chance you may have a fake answer. I mean, what do I mean by fake? When you put this in, it may make this equation impossible to solve. Such as, let me tell you what may happen. For example, sometimes you may get y to be 0. Let's say we got y equals 0, and try y equals 0 in here. Can you guys compute 3 over 0? No, 3 over 0. Put it in a calculator. We'll say undefined. That's what I mean by fake. It may make the denominator 0. You substitute in the denominator that value and it may make 0. That's why they said identify the restricted value. That's fake numbers, fake results can be a restricted value you shouldn't be testing on in the denominator. And in that case, don't put that as an answer. If you get y equals 0 as a solution, just say no solution because this makes the denominator 0. But do you think this can be fake? When you enter this into denominator here, can it make this denominator 0? Minus 63 over 13? No, this is already safe. So I'm feeling good about this. Just test it on. It has only one solution. Oh, sometimes you may get two solutions, two separate y's. And one of them can be fake, one of them can be real. So you need to take off the fake one and say only one solution. Maybe both of them are real. You never know, okay? So you need to test. So this one has one solution, and that was a fraction of minus 63. You can put the minus to the top, it doesn't matter. It doesn't have to be in front, over 33. Okay? Again, do not put anything decimal. Some people like decimals. Take a calculator at 63 and 13. No, that may be an approximate cutoff answer, rounded off answer, which is not correct. We want to stay perfect, so just if it's not simplifying, leave as a ratio. This is fine. Okay. No new tricks. We will rinse and repeat these 4 steps, fifth one optional, 4 steps in every question with more and more complicated things in the denominator. Look, it's getting worse, worser, uglier, ugliest, maybe. This is even worse. Yeah, this is the worst case scenario. Getting harder and harder. 2 still easy type. I want you to check out your monsters. What are the monsters? A plus 8 and 2a, and factor them first. Take the denominators to separate side and analyze them, investigate them. Can I factor a plus 8? How about 2a? I already factored them, 2 and an a. All we need to do is identify each factor and see if there is any overlapping already match. Any matches between factors? No? Do you see anything? No? So what is your bullet then? The bullet, LCD, least common denominator, is all 3 together. No overlapping. Okay? Again, you pick each factor. You list each factor here with the biggest one. You sample one factor from everybody. So I took one, I took one, I took one, and don't repeat them. And always pick the one with the largest exponent. That's the trick to pick the bullet. So there is all of them are single power. There is no repetition, and everything is distinct, different. I take one from each kind and multiply. I like 2a in front, so if you don't mind, I'm going to put it that way. I'm going to reorder these like that. Is it okay? Can I reorder these 2 in front and a in front? I like parentheses later always. So what do? We identify step 1 and step 2. We identified the bullet. This is your bullet. Let's put it to both sides. So 2a, a plus a going to the left. 2a, a plus a going to the right. Right beside these things. Bullet to the left, bullet to the right. You have only one guy on the left, one guy on the right. This is even easier than the first question, because at least here you had, how many terms did you have on the right side? 2. So there was a distribution going on. Bullet was going separated into both terms. But here, single. So it just shows up once on each side. If this was like 5 over 7a, I would put the bullet on this one too, but it's not the case. All right, so let's do the cancellations. What is canceling on this side? This bullet must kill the denominator, remember? So it's gone, the denominator. What is canceling here? 2 and 8 together. So we have 2a times 2 left here. Gone. This is 1. You don't have to show this denominator anymore. You have only 2a and 2 left. Oh no. Alright, sorry about the technical problem. We'll keep going. We'll keep solving it. Just need to rerun this. Alright, we're back. So where were we? Okay, 2a and 2 was what's left on the left side, and on the right just circle the leftovers. So it's 3 and a plus 8. You see, all the monsters are there, no more denominator, so it's a big relief. All you need to do is complete multiplications, clear all parentheses, collect variables on one side, and isolate. Okay? So I see some multiplication going on the left, so it's 2a times 2 is 4a. And I see some multiplication going on here. 3 times a is 3a, right? And I have 8 coming up. Is that right? This is wrong. This is one of the most common mistakes. You not only multiply first one by 3, you distribute whatever is left here to all parentheses. So it's 24, not 8 only. 3 times 8 is 24. Next, I remove 3a from the right side by taking its opposite and putting it into both sides. 4a take away 3a is only a. a equals 24. We need to test this result. Simple check. When I substitute 24 here or there, does any denominator on the left or right become 0? Does it become 0? No. That means if I did everything right here, this must be the answer. There is no fakeness involved here. It's real, 24. Unless I made a mistake here, it must verify my answer here. So there is only one solution we got. Solution is 24. Okay? We good? Any questions? I'll give you a moment to think about this. You have 1 minute. Any answers? No? 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 -2 and 4. Maybe, I don't know. I don't know the answers. Any different answers? Again, if you're right, you earn credit. Okay, let's move it here and see if this answer is right. Last call. Alright, and +2, -4. Anyone wanna flip signs more? Let's see who's right. Maybe. I don't know. Any other different answers? Okay. So what shall we do here is, we first identify the monsters, denominators. So take them apart right here. How many denominators do you see here? I see one here, x. The other one is x squared. No, this is actually double x. X, right? Now, let's choose the bullet to kill both of them. The smallest size possible. We call it LCD. You take each factor only once. You only take one sample of each factor. Now, one may say, oh, to kill this x, I need to have it in my bullet. So one says, oh, to kill this x squared, I have to take this in my bullet as well. So the combination is 1x here, 2 more x's. My bullet is x cubed. Is that right? No, this is a too big bullet. You don't need to waste such big ammunition for such a small monster. So what did I do wrong here? I said you take only one type once, and always go with the biggest, largest power of it. Look, these two factors, the same type, both have x's. This has power 1, this has power 2. So I will only pick one of them, but I go with the largest power so I can get a bullet big enough to kill the strong one. This is strong, same type monster, but this is a weak one. So of course I have to pick a bullet to kill the strong one because weak one is already gonna be killed by that bullet. Okay, so I don't need to combine these two though. Don't go and combine x and x squared. Since they are the same type, only go with the largest exponent of that type of factor, which is x largest power squared. So your LCD, most economical one, best size bullet is x squared, not x cubed. Don't take x and x squared and make x cubed. Okay, it's not wrong, but you will be wasting bullets. It's still okay, a waste of writing multiplication and other steps. So this is my LCD. I'm going to put it next to each monster I see here. So I see these. I'm using some spaces so I can fit in. I have these, so I'm putting this bullet into left. This is the only one with the denominator, so I will put it here, x squared, and I will put it here, x squared. One bullet to the left, one bullet to the right. Am I right? Correct?
Well, you have to put it with everything, so it goes 1, 2.
Right. Again, remember, bullet needs to be distributed to each and everybody on the left and right. This is a crowd. It's not just single this guy. It's unfair to shoot this guy only. This is a combination of two people, two targets. They are combined with a subtraction. You need to put the bullet to the first one too. Okay? X squared must go to 1 as well. Otherwise you're doing something wrong. You can't just take a part of the left side and put the LCD there. You must distribute to each term on the left and right. This is correct. Well, what happens to x squared and 1 when you multiply them? They make just x squared. Here though, always if you have a denominator, there must be some killing going on, cancelling. And one of the x's will cancel with this, and there is still an x left. You need to multiply by 2, which is minus 2x. Okay? We have a minus sign. 2 times x is 2x. Okay? And here, look at this. Both bullet and the monster goes away. There is nothing left. Only 8. Remember, this bullet was strong to kill this weak one, so there is something left out. X's was left, so it's okay, there is something left over. And this one is just the perfect size. They just both go away. Look at this. Now, can you leave X all alone on one side? Compare this equation to this one. What do you see different? Look, take a look at this one. Compare this versus this one. Just imagine a is here. A squared minus 2a, 8. 4a, 3a, 24. What's the difference?
They're already on the same side.
Yeah, what's that?
They're already on the same side.
Yeah, A's are here on opposite side, so we need to bring them to the same side. That's what we did here. These are already on same side. That's one difference. What else? What else is different? There's more significant differences.
X squared.
Right. This one has a power 2 around the value. I wish this was x. I would just subtract x and minus 2x. We would be done. This is x squared. They wouldn't subtract. They wouldn't combine. There is no way you can no way to isolate x's, no way to leave x alone with a square like this. So this is called, what kind of equation is this called? If you have a square around x, this is called quad. Quad means two square, quadratic equation. Quad usually taught as 4, but quad means 2 in Latin, okay? So this is a square equation. So when you have a square equation, you can't get x's alone. You need to bring everything to the left side and factor it. When you see quadratic equation, everything on the left, and factor. That's what you need to do whenever you see square equation. So this 8 must travel to left by subtracting 8 from left side, and it's gonna become minus 8. Okay? Now what shall we do? I said factor. This is chapter 6 material now. What did we in chapter 6? This is called a trinomial, 3-term polynomial, 3-term. When you see these, you need to break it into 2 pieces by this method. Why? Because the leading coefficient is 1. This is an easy trial error method. You take minus 8 nesting to the end, multiply 2 numbers to minus 8. Sum will be minus 2. What numbers do that? What 2 numbers multiply into minus 8 but add up to minus 2? Negative 4 and positive 2. Do you agree? Can it be positive 4, negative 2? No, the sum should be negative 2. So big one should have a negative sign. Negative 4 is the right choice. So it is x, negative 4, positive 2. Okay? Alright, can I clean this intermediate where I'm done with factoring? I don't need this anymore. You better keep it on the side though. I need this space. What is next? Once you factor a polynomial into 2 pieces, like a times b set it into 0, then either a or left side or b, the right piece, can be possibly 0, so you need to set each into 0. And this will give us x equal 4. That will give us minus 2. 4 and minus 2 were the right answers, not this. Okay? Alright, however, I need to test them. Maybe they are fake. How do I test them? Plug them back in, and if it makes zeros here. When you put 4 or minus 2, do you get any zeros, possibly undefined things here? Can you get undefined? No, they are not 0, right? 4 and minus 2 are both substitutable by x, so we're good. They are both answers. So you're gonna have 2 solutions here, and you can put them in any order, negative 2 and 4, right? Separate them with a comma though. Okay? Any questions on this one? So what's the trick on this question? What was different? First off, LCD wasn't just multiplication of each and every factor here. We picked the biggest power factor only. One sampling with the biggest power, and we multiplied each side. Don't forget to distribute. And we ended up with a quadratic equation for the first time. In the first 2, we had the linear one. No powers around the variables. Easy. This was tough. Factoring required in the final stage. Oh my god, it's getting worse. So many variables on top and bottom. but still kind of moderate question. This is a moderate one. And how many denominators, monsters, do you have here to kill? 3. First, put them in here. When you're putting them here, make sure you have factored them. Can I factor any of these? 9. Yeah, don't take just 9. Break it as 3 and 3. And only when you're choosing your bullet size, take one of each factor showing up here, no repetition, and prefer the ones with the biggest exponents. Okay? So to be able to identify biggest exponents, this is not good writing. If there is a repetition of any factor in a denominator, don't write them as 3 and 3. Write it as 3 squared, so you can visually see the strength of the monster. This is a double power monster. This is a single one. So when you're picking one of these, which one are you gonna pick? Or are you gonna take both? Are you gonna take this one and this separately? No, we will only pick one of the 3's, but the biggest monster, worst monster, is 3 squared. Okay? Now there is another type of monsters here, WW. Which one are we gonna take? Or are we gonna take both W and W in our bullet? No, you are only allowed to pick one monster type at a time. You can't double them. So you just choose one and put it here, W. One of each kind, 3 or W, but when I'm picking 3's, I went with the biggest power. Okay? Does it make sense? This is our bullet. Let's shoot. How do we shoot? Put it next to everybody here. Here too. And there too. Let me do it more properly. It's 3 squared W and then the monster coming in. W over 9. Minus bullet first, monster next. Finally, minus bullet first, monster next. Make sense? You just make sure attach a bullet to everybody, every term, and rewrite the entire thing. Next, let the bloodbath happen. Cancellations, right? Cancellations. What is canceling here? 3 squared and 9, because they are same, 9 and 9. Remember, entire denominators must disappear. If there is something left in the denominator, you didn't pick the right size bullet. Go fix your bullet. Okay? So what is canceling here? W. One of the 3's. There is still 3 left. One more 3 left, because this is double 3. Right? 1 3 left. Here, only W. Let me mark leftovers. W and W left. 3 and W plus 3 left. 9 minus and 1 left. So you need to multiply those boxes now. No denominators left, all wiped off, all monsters dead. Great, so I'm on the right path. What does W and W make? Cool. Next, minus, what is left here? 3 times W, look, 3 left and W left. 3W and then 3 left. 3W, 3W plus 3. Yeah, mistakes here. What is the mistake here? Yes. Take a good look at here. It's not just 3W3. It's this. Minus. Don't forget minus. There is a minus here. Minus 3. And then W plus 3. This is in the numerator. but it's a block. This is a block. So whatever comes here multiplies both terms of this. And I have a minus 3. It should not only multiply W, this is correct, but this minus 3 should multiply 3, and we must make, what is 3 times 3? 9. There is still a mistake. It's negative 9. Look, this minus and 3 must both multiply and distribute the 3. What is minus 3 and 3? It is not positive 9, it's negative 9. Okay, what's the lesson we got in this question? If there is a minus, it must be distributed to both terms. Not only minus, but the number left out from the bullet, the bullet leftover number, and minus together must be distributed to both terms. Okay. All right. What else is left here? Minus 3 squared, which is 9, and 1. 1 times 9 is just 9. What's that? Yeah, I mean, you can put this negative 1, and negative 1 times 3 squared is still negative 9. Okay. So if this is 1, you can ignore it actually. It's gone. It's just negative 9 squared. Okay, next. This is what kind of, always identify. Before surgery, you need to diagnose what's wrong with your patient. This is your patient. What kind of patient is this? Linear or quadratic? This is quadratic square. What did I tell you in quadratic equations? You need to get everything on the left first. And I still see something on the right. What is it? Minus 9. So I need to get this to the left. How? By adding 9 to the both sides. Oh, something great is happening actually. You see that? These are canceled to 0. And at the same time, this thing also canceled. There is nothing left. You don't have to put 0 here. There's nothing left. Okay, how do I solve this now? I wish there was something left here so I can do this method. There is nothing left here. What can I do? If you want, if you want to do trinomial method, you can make this 0. And you can make this minus 3. Sum is minus 3. Multiplication is, product is 0. What two numbers multiply to 0 and add to minus 3? You can do that kind of thing. This is tough. Don't make it harder than it is. It's just, if you only have 2 terms, it's called a binomial. Bi means 2. Quadratic, but binomial at the same time. This is easier than guessing game. What do I need to do? Anyone? Yeah. See if there is anything common. In 3 terms, there may not be nothing common, but in 2 terms, usually there is something common, which is W. I can pull 1 W from each guy. When I remove a W from W square, there is still W left. And when I remove W from minus 3W, it's minus 3 left. Okay? Look what I'm going to do now. Set each into 0. Left and right sides, left and right piece, both must be set 0. W is either 0 or W is 3. This is a great moment. Because for the first time, you're going to encounter something. We are going to encounter what? You will be surprised. 0 and 3 you think are your solutions. You have 2 solutions. No guys, you don't have 2 solutions. Incorrect. Why? We don't have 2 solutions. I got 2 solutions. Why? Right, this one is fake. This is the real one. Why? What's wrong with 0? Because when I substitute 0 in here, in one of these denominators, left or right, what do you get? What is 1 over 0? Is 1 over 0 a number? No, you cannot solve this. You cannot set this equal because these are undefined. So you've ended up, for the first term, you ended up with a fake solution. There is only one solution. One solution. That's only 3. Okay? Just because you did the entire algebra doesn't mean you got the right solutions. Some of them may be fake. Okay? So we'll continue with the remaining 3 questions, but they are hard questions. So why don't you take a look at tonight, take a look at them, try how hard they are, and come back tomorrow we do together, okay?